How's everybody doing out there? Welcome to another cloudy Thursday afternoon. Notice it's never beautiful and sunny out on Thursday afternoons. That's because the powers that be want you to be watching AP Calculus so you can review for your AP Calculus exam, which is in how many days? Roberto Clemente, Ruben Sierra, 21, 3 weeks. 3 weeks. Wow. The whole year will come down till 3 weeks from today. But I know you're all ready. So based on that bit of introduction, who do we have? We already have a caller? Hello? Molina?
Yes.
How you doing?
Fine.
Who is this?
Delia.
Delia, how you doing?
Doing okay.
Just okay?
Yes. You're doing great. No.
Where's Miss Brzezinski?
She's right here.
Hi, Miss Brzezinski.
Hi, Greg.
Could you go to the, do we have a problem? Okay.
Oh, no.
Hey, let's show the first problem here. Hey, let R be the region bounded by y equals x equals cosine x equals 1. How about let's find the area of R?
Have them drawn.
What's that? Find the area of R. What would we do, Delia? I'm looking for your picture.
Draw a graph.
Draw what graph?
E to the x.
What does e to the x look like?
Increasing.
It is increasing, right?
And quantity.
What do we know?
1, 2.
What do we know about? What do we know about the y-intercept of e to the x?
1.
That's right. It's 1. So therefore, if y equals e to the x, it looks like this. Okay? Looks like that. Now what about cosine? And x equals 1 is a vertical line that looks like this. What do we know about cosine x? When x is 0, what's cosine?
1.
And okay, here's a tough one. When x is 1, is cosine above, is it above 1 or below 1?
Below?
Yeah, because it'll look something like this. So we're talking about this region right in here, right? And we know it's above 0. Why do we know it's above 0? That's a real hard question. Why do we know that the cosine of 1 is a positive number?
No, oh my. No, you can't even see that.
Anyway, so why do we know the cosine of 1 is a positive number? That's a hard question. Hey, let's skip that. We'll get that for the next caller. Why? The question is, why do we know the cosine of 1 is greater than 0? But how would we find the area of this region, Delia? When finding the area between two curves, what do we do? What's the magic word?
Integrate.
Integrate. And we want to integrate from what to what?
From 0 to 1.
We want to integrate from 0 to 1. And what do we do from there?
Top curve minus bottom.
Right, we're dealing with, in terms of x, it's just the top curve minus the bottom curve. So which one's the top curve?
E to the x.
So it's just e to the x minus cosine of x, right?
Mm-hmm.
So therefore, excellent. How do you integrate? How do you integrate that?
E to the u times the derivative of u.
That's the derivative of e to the x. What's the integral of e to the x?
U to the x.
Right, and what's the integral of cosine x? Sine x, right? So the final answer would simply be e to the 1 minus sine of 1 minus e to the 0 minus sine of 0. What is e to the 0 minus sine of 0?
1.
Yeah, because e to the 0 is 1 and sine of 0 is 0. Delia,
Huh.
Excellent job. Are you nervous?
Yes.
I don't blame you. I'm nervous too. I pulled a muscle in my back, and it's making me nervous. Anyway, Delia, call in again. Okay, great job. Christy Knapp!
Hey.
Is this the beauty queen?
Yeah.
How you doing?
Fine.
Is somebody talking in the background?
Yeah, it's Emily.
Emily. I'll tell you. Hey, let's take a look at. We can do volumes at Bryan Adams now, right?
Yeah.
Okay, I want to make sure it's okay.
We got the volume down.
Let's go to this problem. Everyone, call on in. We have 972-925-3123. Let's talk about this region again. Y equals e to the x equals 1, and cosine x. If we want to rotate this region about the x-axis, if we want to rotate this about the x-axis, what would we? Wait. What would we do, Christy Knapp?
It would be pi times the integral.
Pi times the integral. By the way, Christy, do you know that the cosine of 1?
Yeah.
Do you know why? Before we go on, do you know why the cosine of 1 is greater than 0? Who said yes?
That's Emily talking in the background.
Why is the cosine of 1 greater than 0?
Oh, because you plugged the 1 in and.
Well, without a calculator, how would we know? Okay, well, we'll skip to that.
Okay.
We'll see if Butters wants to do it. But hey, Christy, so you said if we rotate this about the x-axis, it's pi times
the integral of e to the x squared.
from what to what?
Oh, from 0 to 1.
From 0 to 1.
Of e to the x squared minus cosine of x squared.
Okay, and that's fine. We'll leave it like that. Hey, let me ask you something. That's excellent job, Christy Knapp. Excellent job. Does this simplify? What does this e to the x quantity squared simplify to?
E to the 2x.
Yeah, excellent. And what would be the integral of e to the 2x if we had to integrate that?
2 e to the 2x.
The integral, not the derivative.
Oh.
If you had to take the integral of e to the 2x, what would it be?
2 e to the 2x. It's not 2 e to the 2x?
Nope.
Oh, it's 1/2 e to the 2x.
Right, because the derivative of that would be e to the 2x times 2, which would be multiplied times 1. Hey, Christy, you know what you get?
What? Woo! Yay!
Fine job.
Thanks.
Fine job. Hey, call in again, okay?
Okay.
Okay, Christy?
All right.
Okay. Butters!
Hi, how you doing?
How are you doing?
Good.
Are you doing good?
Yep.
What's Miss Harmon serving out there today?
Okay. Doritos, the toasted corn ones, and this cheesy dip thing.
The cheesy
Chips
dip
Ahoy.
thing.
Chewy Chips Ahoy.
Chewy Chips
And, and Baked Lace Original.
When you look at the Chewy Chips Ahoy, do you think of a volume problem? Do you think of a disc, perhaps?
Not really.
Okay. Hey, Butters,
Yeah.
why is the cosine of 1 greater than 0?
Cosine of 1 greater than 0.
Yeah, why is the cosine of 1 greater than 0? How do you know that without a calculator?
Because cosine of 0 is pi over 2, which is 1.5.
Hey, cosine of 0 is pi over 2?
Never mind. Cosine is pi over 2 is 1.57 something. It's pi over 2, right? So it's above that. It comes before.
The cosine of 0 is equal to what?
1. Sorry, that's the wrong
Okay.
one. And cosine of pi over 2 is 0.
Okay.
And which is 1.57 something.
Okay.
So 1 is going to be in between, which is going to be positive.
Butters?
Huh?
You like margarine, Butters. It's excellent. Okay. Hey, Butters,
Yeah.
I'm going to give you a harder problem, Butters.
Oh.
Okay, you ready?
Yeah. Hopefully.
Let R be the region bounded by y equals x squared plus 1 and y equals, how about e to the 1/2 x?
Nah.
Yeah. Find the volume.
Around the y-axis.
Nope. If the base of R
what is it, square?
If the base of R, if R is a base where cross sections perpendicular to the x-axis
Okay.
are semicircles.
Semicircles?
Yeah.
Okay. Let's draw this first.
Okay, how do I draw it?
Draw a little thing.
Draw a little what?
Draw the little y-axis and x-axis thing.
Hey, how do we know which one's on top?
Let's plug in some numbers because I'm not sure.
Okay.
Let's make a little chart, x and y.
Make a little chart, x and y.
Okay, that's going to be for our first function. You get 1, 0, let's do -1, 0, 1, and 2.
-1, so that's 2, 0 is 1, and 1 is 2, okay?
And then do the other y. Same axis.
Okay, -1, what's e to the -1/2?
E to the -1/2 is 1 over e to the 1/2, which is, oh my god, some numbers.
Well, is it less than or greater than 2?
E to the 1/2, that's
E to the
square root of e.
E to the -1/2 is
Yes.
1 over e to the 1/2.
1 over, which is 1 over square root of 2.7128.
So what's like 1 over the square root of 2? What's square root of 2 approximately?
1.4.
It's more than 1, so this number is less than 1.
Uh-huh.
So, okay, that's less than 1. We plug in 0, we get 1.
Yes.
Oh, they're equal.
And then we plug in 1, and then that's e to the 1/2, which is square root of 2 point something, so 1.4. It's still less.
Okay. So what do we know here? Well, we know what x squared plus 1 looks like.
Yes, it's always above.
We know x squared plus 1 looks like that, right?
Uh-huh.
So now the question is, e to the 1/2 x, does it look like this? Or does it look like, because we know it's 0, it's 1, and then it's going to tail off like that. But now, which one does it look like? Is e to the 1/2 x above or
No,
below?
it's below.
It's below?
Yes, it's below because all the y values are below.
Let's check.
Oh wait, and at 2 it's below, but then later I don't know.
Okay, well, let's check. Let's check. Here's the two functions. We'll go zoom 6.
Okay.
That's x squared plus 1 and too close to call.
Yeah, let's make it a zoom 4.
Let's zoom it in.
Okay.
Well, that's a bad picture. Here it comes. It is. Oh, it's above! How can it be above? How's that possible?
Oh, that's because it's in between. Like at that point, at the point that we plugged in, it's below, but in between is different.
That's right. So e to the 1/2, and in this case, this would be a graph and calculate problem, and to find the points of intersection.
Yeah, let's do that first.
Well, we know it.
It's at 0, 1.
Right. So if we enter 3 times. Okay, so we got 0.580.
Write it down somewhere.
Okay, I will. Thank you. 0.580. Miss Harmon, I love it when she bosses me around. She reminds me of my wife.
Okay, so we have 0 and 0.580.
Well,
let's draw it again.
Let's draw it again, shall we?
Yes.
This is x squared plus 1. This is e to the 1/2 x.
Okay.
Okay.
Now.
So this is x squared plus 1. This is e to the 1/2 x. Okay. Now what I want you to do is I want you to find.
Yes, I know what you want me to do.
Yes. Okay. Well, can I repeat it for for our viewing audience?
Yes.
If every cross section here, if this is a base of a solid where every cross section perpendicular to the x-axis is the diameter of a semicircle, what would the volume of that figure be? You just set up the integral. You should be able to set it up in about 30 seconds.
Yeah, it's 1.5 pi, and then integral.
1.5 pi.
Isn't it pi r squared? Didn't you say semicircles?
Yeah, this is the diameter of a semicircle.
Yeah, so it's 1/2 of the function squared.
Okay, okay, well, tell me what to write down.
Put an integral there. Okay. There we go. From to 0.580, I guess. Is that 580? Yeah. It's 1/2 of the upper minus the lower. So it's e to the 1/2 x minus that there squared. Okay, wait. The volume of a... Let me see, that's like that. Is it pi r squared? Pi r squared would be the area of a circle, right? Pi r squared.
Yeah.
And half of a circle is 1/2 pi r squared, right?
So let me put a pi out there, okay?
Yes. There we go. Okay, so put the 1/2 and the pi outside.
Okay, so you think that's right?
I think so.
Buzz.
And put a dx outside.
No bell for you today.
Why?
Okay, let's actually spend a couple minutes.
Oh, wait, the 1/2 has to be inside. It's 1/2 of the function squared.
Right, because here, let's take a look at this. And we're going to do this. We're going to give magic formulas today where you automatically, you just know it's 1/8 pi r squared every time. Because if this is y,
Well, yeah, because you squared the 1/2.
What's the area of this semicircle? It's the radius is 1/2 y, right?
Right.
So it's 1/2 pi r squared, which is this, which is 1/2 pi times 1/4 times y squared. So whenever you see a semicircle, it's just 1/8 pi r squared. That's all you have to do. So automatically, when you see semicircle, it's 1/8 pi times whatever the area would be squared. Automatic, 100% of the time when there's semicircles perpendicular to the x-axis.
Yeah, just like when it's like a lesson triangle, it's always, wait, I forgot.
Right, but as in this show, we're going to show you the automatic shortcut that you should memorize for semicircles.
I never memorized those formulas.
Well, okay, well that's good, because you can work them out. But make sure you get them right next time.
Whatever.
Okay?
I haven't done it in a while, that's why.
All right, well, no, and that's no excuse in 3 weeks, babe. Hey, listen, hey, great job.
I'll still get my 5, ha.
Call in again, okay?
Bye.
Hello?
Is this the small cracker?
No, it's the big cookie.
The big cookie, okay. I thought it was a small cracker.
You're the small cracker.
Did you get it?
Yeah.
Do you think that's funny?
Not really.
I don't think so. Hey, let's talk more about this volume thing, since there's always a volume question on the thing here.
Okay.
Let's say you have y equals x and y equals x squared. All right?
Okay, that's it.
Well, if you want to find the area bounded by these two
Yeah,
terms.
okay, first thing you gotta do is draw a graph. I want my graph.
Which one's on top?
Okay. Okay. The first you gotta draw y equals x, which is just a straight, and then y equals x squared.
Is it above? Is x squared above or below?
Below.
It is below. Okay, so we're talking about this region right in here. Okay.
Okay, which
Wait. Hold on. Where? First of all, where do they meet? What is this point?
1.
They meet at 1. Okay. Now, to find the area, that's easy to do. It's just 0 to 1.
Yeah.
Okay, but hold on. Hey, small cracker, hold on.
Big cookie!
Small cracker, look. If this region, if the base of this region, if you get this right, you will be truly the large cookie.
The big cookie!
Okay. If the base of this region, if the cross sections perpendicular to the x-axis are equilateral triangles.
Oh, well then, the height
Find the volume if they're equilateral triangles.
Okay, first I want you to draw a picture of one equilateral triangle.
Okay.
Okay. And then we know that the base is twice the height.
The base is twice the height?
The height is half the base.
The height is half the base. You're saying the height of this is, if the whole thing is y, this is 1/2 y? Is that what you're saying?
No.
I'm glad. Okay, hey, Cook.
Square root of 3 over 4.
Wait, you just can't yell out the final answer without doing any work, Cookie. Okay. Cook, if this is y, if this is equilateral, this is 60, 30, 90, this bisects the side, so this is 1/2 y. If the side opposite 30 is 1/2 y, the side opposite 60 is square root of 3 over 2y.
Right.
So the area of the whole triangle is 1/2 times the base times the height. So it's square root of 3 over 4y squared. That's the area of one of those triangles. So
I was thinking isosceles.
So if you just know the formula, every time you think of equilateral triangles, it's just 0 to 1 of square root of 3 over 4 times whatever the area would be, which is x minus x squared, quantity squared. That's it.
Right, and then you just foil around, bump it up and divide.
Bump it up and divide, baby! Bump it up and divide! Okay, hey, Big Cookie?
Yeah?
Fine job. You
Thanks.
and Butters both missed 2 volume questions now. So, that's but we'll get them right. We'll get them right next time, right? Good job, Cook. Keith,
Thanks.
Big, smart.
Bye.
Bye. Annalisa Calvert.
Yes.
You old heartbreaker. How you doing?
Fine.
Okay, you ready for another question?
Yeah.
Oh, sorry. I love it when there's whispering. It's like everybody can hear. Hey, can you guys hear on the TV, you guys whispering back and forth, or am I the only one who can hear?
You're the only one, I guess.
Oh, you know what? I'm the only one, I was just told. So, like, when you guys whisper the answer. Anyway. But, Annalisa?
Mm-hmm.
How you doing?
Fine.
Okay, let's take a look. What was that?
Nothing.
What about x squared minus 1 and y equals, how about y equals 2? Let's take a look at the region that's bounded by these two curves.
Okay.
So what would that look like?
A parabola.
Parabola. Talk math to me. That's great. It would look like this, right? This is 2. This is negative 1. It would look like this region right here, correct?
Uh-huh.
Okay, you ready?
Uh-huh.
If this is the base of a solid figure, and if each cross section perpendicular to the x-axis is the hypotenuse of an isosceles right triangle,
Okay.
what would the volume of that figure be? Or how would you set up the integral to find the volume?
You integrate.
Okay, good.
And it's pi in front of the integrating thing. No, wait, never mind. That's for another thing.
That's for rotating. When you don't rotate, it may not be pi. By the way, what are these numbers right here?
What are they?
What number? Yeah, what are those?
They're like zeros.
Yeah, but what's the x-coordinate?
1 and negative 1.
Okay. Negative 1 and 1. Right, and why do we know that?
Because you set your two things equal to each other.
Yeah, well, you don't have to set them equal to each other. You just set x squared minus 1 equal to 0 because that's where it crosses the axis.
Oh, that too.
And so you realize just numerically it'd be negative 1 and 1. Okay, so and this number out here is negative 2 and 2, right? Well, not necessarily, but it'd be you would set x squared minus 1 is equal to 2. Be x squared is equal to 3. It's actually x equal plus and minus square root of 3.
Okay.
That's what these numbers would be.
Okay.
You see that? So these would be plus and minus square root of 3. Okay. So help me out here.
The equation for that is 1/4 of the hypotenuse squared.
Okay,
So
it is 1/4 because the way you look at it is that if it's equilateral, if this is y, then your 45, 45, 90-degree triangles, it's y divided by square root of 2.
Oh,
And the area of this triangle is just 1/2 y squared. So it's 1/2. And what would we integrate it from? What would be these points right here?
Let's see. If you set them, it'd be negative square root of 3 to square root of 3. Is that right?
Yeah, it sure would be. Going to run into a couple things, but that's fine. And so, what would we do? Okay, and then what would we do? Help me out from there. What would the what is this? How would we figure out what this is? What the y is, or the like if you have to figure out the area of this region, what would it be?
Well, for just the area,
Yeah.
it's top minus bottom.
Yeah, and so what is the top?
2
What's the bottom?
x squared minus 1.
And so that's all you would do here also. It's the same thing. It's just top minus bottom, but squared. So it's like if you know how to do the area, Annalisa, if you know the area of the region, if they were cross sections perpendiculars by squares, all it is, it's the area
Squared.
squared. If it's semicircles,
1/8.
semicircles, it's 1/8 times pi times area squared. If it's equilateral triangles,
Square root of 3/4.
excellent, excellent, square root of 3/4 times area squared. And if it's, and they can't ask anything else, this is it. Isosceles right triangles, it's just 1/2 times the area squared. That's it. That's all it is. So if you know how to figure out the Annalisa,
Hold on. Why not? Miss Arthur says we're having trouble.
we're having trouble.
Why?
I still think that isosceles right triangle should be a fourth.
What's that?
She says the isosceles right triangle should be a 4th.
Why is that?
Why is that?
Because it's 1/2 times 1/2? Right, it should be 1/4. Thank you. That's correct. It's 1/4 y squared. That's right, because it's 1/2 y times square root of 2 times y squared root of 2 is 1/2 y squared, and you have to multiply times 1/2. So therefore, the isosceles right triangle, it's just the formula is 1/4 times the area squared, right?
Can you fix the problem?
Can I fix the problem?
Like up top where we did it?
Make
yeah.
it 1/4.
Thanks.
Okay. I was listening to you, Annalise. I believe that you were right.
That's what I told you, but
I
you
know.
changed it yourself.
I know. I'm sorry. Oh, you told me 1/4?
Yes.
Oh, wow. We'll have to review the tape on that. Hey, fine job, Annalisa. So it makes the volume stuff pretty easy, right? Okay. Good job. Hey, why don't you give the phone to someone else and we'll come back to you, okay? Give the phone to Emily.
Okay.
Okay. Hey, Dennis!
How's it going, Mr. Fleischer?
What's going on, bud?
Nothing much.
Go
Go ahead.
ahead. What were you going to say?
I have a message for Anna from Brian Adams, or to Brian Adams from
Uh-huh.
Susanna.
Uh-huh.
She
I'm
says-
Lisa.
Yeah, she says good luck at the game tonight.
Good luck. Who's playing? I mean, what subject?
Soccer.
Soccer. Annalisa. I mean, WTY playing Brian Adams?
No, it's just the what? The feeders.
The feeders? The feeders are playing?
I guess.
Okay, I don't know what that means, but the middle schools?
It's a select.
Oh, okay. Hey, good luck at the game tonight. Okay. Hey, Dennis.
Yeah?
I got a great question for you.
I don't know.
We're gonna stay away from the volumes here. I want you to find if y is equal to x natural log of x. Give me the x and y coordinate of all relative extrema. You cannot use your calculator. And you have to tell me if it's a relative max or relative min.
Well, we take a derivative.
Okay?
So it's ln x plus 1.
Okay, because it's... Well, how'd you do that in your head? It's the first times the derivative of the second, which is that, plus the second times the derivative of the first, which is 1. So it's ln x plus 1, or 1 plus natural log of x. Excellent, okay. So we got that down. So that's the derivative. What do we do from there?
Set it equal to 0.
What's that?
Set it equal to 0. Find out where it crosses the y-axis.
Set it equal 0. So from there, well, if we set it equal 0, well, let's solve for it.
Excuse me?
Let's go ahead and solve for this.
Oh, okay. So subtract 1. So then x equals e to the negative 1.
Well, tell me how that's right. Emily, call back in. Delbert didn't mean to hang up on you. Go ahead.
So subtract 1,
Natural log of x is equal to negative 1.
and then e both sides.
So it's e to the natural log of x is equal to e to the negative 1. Okay?
So x equals e to the negative 1.
Okay, now is this a relative min or relative max? How can we tell? Hey, what's the domain of this function? Dennis.
Yeah. What's domain? It's would it be? No, because it closes at 1. No, but doesn't it go like that? I'm talking to B.
That's okay.
Then it.
What's the domain?
All positive x's.
Yeah, because for natural log of x, if you could visualize the graph of natural log of x, it looks like this. Notice that it's for values greater than 0. So therefore, this is for, the domain is for x is greater than 0, okay?
Okay.
So that's the domain of the functions. But how can we find out if this is a relative max or relative min?
Well, do a chart.
Do a chart, okay? So what should I do? Tell me what to do.
Pick a number less than e to the 1, negative 1.
Well, how can we take a number less than e to the negative 1?
How about 1/3?
1/3?
No.
Well, we don't have a calculator on this problem. So we need to find out if this derivative, if we plug in, we don't know what the natural log of 1/3 is, or maybe we do. If you want to plug in 1/3, which would be less than e to the negative 1, because that's e to 1 over 2.7, how would we know if the natural log, how would we figure out what the natural log of 1/3 is? Let me give you a hint. Well, how can we simplify this?
Natural 1 minus natural 3.
Okay, natural log of 1 minus natural log of 3.
What's the natural log of 1 equal to?
0.
Is the natural log of 3 greater than or less than 1?
Less than.
How do we know it's less than 1?
No, it's greater than because of the ln function goes. It's all positive.
How do we know that why do we know the natural log of 3 is greater than 1?
Because ln of 1 equals 0.
Well, ln of 1 is equal to 0, but we want to know why it's greater than 1. Not why it's greater than 0.
E to the 1 equals 2.7.
Natural log of e, what does natural log of e equal?
1.
So if the natural log of e is 1, the natural log of 3 has got to be greater than 1 because it's natural log of 2.7. So therefore, 1 minus something greater than 1 would be negative, right?
Mm-hmm.
And we only go up to 0, but it's actually greater than 0. And how do we know if we plug in a number greater than e to the negative 1?
E.
What's that?
E.
If we plug in e, there we go. And we could have plugged in e to the negative 2. It would have been a little bit easier.
Okay.
But excellent. If we plug in e, what do we get if we plug in e? It's a positive or negative?
Positive.
So therefore, e to the negative 1 is a relative min or relative max? Which one?
Min.
It's a min. What's the y coordinate?
Plug it into the top.
What do I get if I plug it into the top? I got x is equal to, we got y is equal to x natural log of x. And we got the minimum is x is equal to e to the negative 1. If we plug it in, we get y is equal to e to the negative 1 times natural log of e to the negative 1, which is equal to what? What is this, Dennis, what does this equal? What does this underlined part equal?
Negative 1?
Negative 1, okay? So it's y is equal to negative e to the negative 1.
Mm-hmm.
Okay, so therefore, which is equal to negative 1 over e. So the x coordinate is 1 over e, which is somewhere around 1/3, and that's around negative 1/3. So the minimum is right here. Somewhere right around here. Okay. Now what I'm going to do is, hey, get Butters on the phone for a second,
All
since she keeps on interrupting you anyway.
Yeah, I know.
Hi.
Hi, Butters.
Hi.
I got a question for you, Butters.
Oh, okay.
And this problem, this is a relative min, right?
Right.
Because so we know the graph, since f prime changes from negative to positive. So I want you to tell me the x-intercepts of this function.
X-intercepts?
Yeah.
Set it equal to 0
Okay, so we got x natural log of x
equals to 0.
equals 0.
Okay, the first one is 0. One intercept is 0, right?
So x is equal to 0. Is that the only intercept?
Let me think. Is natural log of x ever going to be 0? E to the 0 is 1, so 1, I think.
All right, so we set both these equal 0, and we get x is equal to 1. But x equals 0 is not an intercept. Why?
Yeah, it's a vertical asymptote. It never actually.
It's not a vertical asymptote. A vertical asymptote would only occur
Yeah,
if
never mind.
a denominator. But this is outside our domain, right?
Yeah.
So I have a question for you.
Okay.
How is it possible if there's only one intercept and the graph decreases, if it decreases and increases, it cannot look like this because it doesn't cross the x-axis.
Okay.
So how is that possible?
But why would 0 not be an answer?
Because the domain of this function, remember the domain is that x is greater than 0.
Oh, yeah, right.
So we know it's not going to look like that.
Yeah.
So I want you to, in a couple callers, we're going to figure out how this works, okay? Bhumika Kapadia from Brian Adams, this is going to help us out, okay?
Okay, cool.
All right. Hey, Rocio!
Hey.
Rocio!
No. What?
Rocio?
Yes.
How we doing?
Fine.
Jaguars. Say Jaguars.
Jaguars.
There we go. All right. Hey, let's, want to do another volume question?
No.
No. Please?
Please? Okay. Fine.
Okay.
Whatever.
Whatever. I like that, the one that I almost did here. How about, let's do y equals 3 and y equals, I like this problem right here. Y equals x squared minus 2. Okay? First of all, how would we find the area? I want you to set up the integral that finds the area of this.
Okay. Graph it. Go down to, and that's a line.
So it looks like this, right?
Uh-huh.
Okay. This is negative 2 and this is 3. No yawning. No yawning.
I'm sorry.
Okay. So I want you to set up the integral that finds the area of this. Just set up the integral that finds the area.
Okay. Pi equals. No. Area.
Area.
Okay. It's integrating from 0 or times 2.
What's that?
2. Oh, we're doing halfway. We're doing it halfway, right? So, right, 2.
You want me to integrate it from 2?
No, outside. We're doing half, so we could do from 0 to whatever, you know?
Oh, you want to just do the half since it's symmetric. So 2
2
times 0 to what?
From 0 to square root of 3?
Y square root of 3.
No. From square root of 5.
Because we want to use this point, right? We want to use this point right here, don't we? Because we want to take all the area from 0 to there. And how do I get square root of 5, Rocio?
Oh, you said x squared minus 2 equals to 3.
Excellent. So it's x squared is equal to 5, so x is equal to square root of 5. So it'd be this, and then it'd be top curve minus bottom curve, and that's how you'd set up the integral for area, right? Too easy, right?
Of course.
Okay, now, of course, I like that. Now, if we wanted to find the volume of this, if each cross-section perpendicular to the x-axis was a square, how would we do that?
Okay. One side of the square is going to be the function, right? Put a square.
Each cross-section perpendicular to the x-axis is a square.
Okay.
So how do we find it?
We square it, the function. What's inside the...
Tell me what to do. Tell me what to write.
Everything, just to square the whole thing.
Everything except just the squared, right? Simple as that, right? What about if each cross-section perpendicular to the x-axis was a semicircle? What would we do?
Pi r squared over 2.
No. If each cross-section perpendicular to the x-axis...
Pi over 8.
Pi over 8. Just multiply times pi over 8, okay? And that's it. What about... I'm going to take it out. Now, what about if each cross-section perpendicular to the x-axis was an equilateral triangle? What would you do?
3 over 4 pi.
Square root
of 3 over 4.
It's just a simple formula. It's that easy to do. Multiply times square root of 3 over 4. And finally, the cross sections. If each cross section was the hypotenuse of an isosceles right triangle, what would that be?
Huh?
If each cross. What's that?
1/4.
1/4 or 1/2?
1/4.
Yeah, I know. I'm just kidding. 1/4. All right. That's it. Isn't that great, Rochelle? Okay, fine job. Get your bell.
Bye.
Red Jack Don't make a cup of tea.
Hi.
I got a great. Were you paying attention when I called your name?
No.
Well, you better start because this is BC, baby. BC.
Oh, great. Miss Arthur.
This is x natural log of x. Okay, and what Butters and the great Dennis Bowser. Dennis Bowser was my next door neighbor for many years. You know that?
No.
Okay.
I don't know what you just said. What'd you say again?
Nothing. It's if you have, we found a minimum at 1 over e. We found that 1 over e comma negative 1 over e was our relative minimum, and we found that since the derivative changed from negative to positive, that the function decreased and increased. We also know, and what is, I don't know if you're paying attention, what is the domain of this function?
All positive numbers.
Okay, very good. X is greater than 0. So we want to know, now think about it, if the domain is greater than 0, that means the function stops. So how do we know? The graph is going to look like something like this. Well, it's not going to look like that because we know it doesn't cross the x-axis. So how do we know, how can we find out where does it stop there? How can we find out where this circle would be? Since the domain is greater than 0, how can we find out where that point is?
Would you like just take the limit?
Yeah, you sure would. You take the limit. The limit as x goes from 0 to the right of x natural log of x. And how do we do that?
Cause you can't plug in. You just look, right?
Well, if you plug it in, what do you?
You get a 0. You can't.
Well, what happens when you plug in? It's 0. What's natural log of 0 equal to?
It's undefined, isn't it?
Right, because if the natural log of x looks like this, what would the limit as x approaches 0 from the right of natural log of x look like?
That way, right?
Well, take a look. Just look at the graph, Bhumika. This is natural log of x, and as you approach 0 from the right, what is?
From the right. Okay, it's gonna be 0 then.
It's going to be what?
0.
What is the y value that's approaching?
Negative. Infinity.
And to be negative. Do you see that?
Yeah, because you're going from the right and it's going, yeah.
Okay, so what we really have here is 0 times negative infinity.
It's indeterminate.
It's indeterminate. And when we have indeterminate, what do we do?
Where you drive the top and drive the bottom. L'Hopital's rule.
L'Hopital!
But we don't have a top and a bottom.
We don't have, we just have 2 tops.
Right.
Okay? And anyway, and we also need 0 over 0 or infinity over infinity. How can we make this thing to be either 0 over 0 or infinity over infinity? How can we manipulate this so we'll have a top and a bottom? BC concept, baby, BC.
X to the bottom.
And I think it's good for AB students to learn the L'Hopital's rule because it makes things simpler.
Could you take the X to the bottom or something like that?
Something like that. I think if you rewrite it like this, now you have negative infinity over infinity, which is now in L'Hopital's rule. Now it's in that form.
So 1 over X.
So the limit as x approaches 0 from the right of 1 over x, what's the derivative of 1 over x?
Negative 1 raised to the X to negative 2.
So what does this simplify to?
Negative X.
negative x. So when you plug in 0, you get 0.
Right.
So therefore, the graph looks like this, where this is 1 and this is e negative e. It stops right there. Do you sort of see that? We'd have to find the limit for that. You know what I'm talking about?
Mm-hmm.
It's a pretty hard problem, but this is L'Hopital's rule, baby. That's the only way you'd be able to graph that to get that the right answer.
Okay.
Bhumika,
Yes.
are you going to come April 28th?
Yes.
You promise?
Uh-huh.
Okay.
Okay.
Stop by and say hi.
Okay.
All right, bye.
Bye.
Butters!
Hi.
Did you get that one?
Yes, we found out it was 0, and then, but we didn't know like how to prove it because we did it in calculator.
Well, you cheated, basically. You cheated.
Miss Harmon did. She told me. No, but Miss Harmon showed us L'Hopital's too.
Hey, L'Hopital's rule, it's great. You know why? Because there are problems. Let me show you a problem that with L'Hopital's rule becomes, the fact that she taught you that is awesome, even though it's really not on the exam. You know, it's not on the exam because the college professors hated when they wanted to talk about limits. Students who took AB calculus maybe didn't pass the exam. They came into college and said, well, just L'Hopital it instead of paying attention to limits. But a problem like this that looks hard, it's like the limit is h goes to 0 of
0.
Thank you, Butters, for that help. How about 0 to h of square root of t plus 1 all over h.
Wow.
This problem, you could have this, and there's another way to do this beside L'Hopital, but this is simply a 0 over 0 problem. This is a limit where it's 0 over 0.
Oh, yeah. So, what, we just have to take the derivatives and plug in again?
And so what's the derivative of the top?
It's just square root of t plus 1.
Square root of what?
T plus 1.
Square root of what?
H plus 1.
Yeah, it's with respect to h. So it's square root of h plus 1. All over the derivative of h is 1.
Yeah.
So the answer,
So plug in 0.
And the answer is 1.
Yeah.
And there's another way to do that, which we don't even have to get into. But isn't that, so L'Hopital's rule, a lot of times with the limit, there's an alternate limit definition. There's an alternate limit definition that is hard to recognize, but if you know L'Hopital's rule,
it's easy to do, and they don't like that, huh?
as a matter of fact, let's show you another one. And on all the limit as h goes to 0 of or delta x or whatever. If you have something like 3 times x plus h squared minus 3x squared all over h. Now, you know that
This is the derivative of 3x squared.
What is right, it's 6x, but this is also L'Hopital's rule, because if you take the derivative of the top, we're taking it with respect to h. When you take the derivative with respect to h, this is a 0. The x is a constant.
Mm-hmm.
So when you take it with respect to h, the limit as h goes to 0 of 6 times x plus h times the derivative of what's inside is 1 all over h, you still get 6x. Do you see that?
Yeah, you do.
Because you're taking the derivative with respect to h, so this x is a constant and it's 0
Oh,
down.
you mean over 1.
Right, over 1. Thank you. Very good. Over 1. It's like the 1/4 thing. But the but I mean, so L'Hopital's rule, is just a really valuable thing to know. Anytime you have 0 over 0, it can bail you out on a lot of problems, and it's a good thing. Hey, let me give you a problem here. Let's see how quick you are. All right.
Oh, come on.
Oh no, you come on. It's not that hard. Buttons!
Okay, continuous function on the closed interval. And the greatest possible value of, dude. Is that water? So the function
because you may be drowning after this problem.
So it's between 2 and 4. The function is between 2 and 4.
Yeah. It may be too easy of a problem for you.
I don't know.
What do you mean you don't know? Get the answer. Don't give me that.
Like, I'm thinking.
What was that?
What is that?
I don't know.
Oh! Wait, it could be...
Is somebody giving you the answer?
Can it be...
Wait. Who just said that in the background? Is that Dennis?
Is that 8? Yeah, we're looking at the board, what Miss Harmon's doing.
Oh. So why? Oh, so we're cheating. Butters, yeah, because if F is,
Yeah, let's draw that. Yeah, it's best if we draw it.
if this is between 2 and 4, if we want the area to be the greatest.
Yeah, so just 2 times 4 is 8.
Right. Let me ask you another question here.
Okay.
Well, let's just do something simple here.
That one was simple but tricky.
Hey, just because you missed it,
I didn't miss it. Miss Harmon told me the right answer.
which of these is the greatest? In this picture, which of these is the greatest?
Okay, let me see. F of 1 is 0. The slope looks like 1. And F of 2 is negative, so it's the second one.
Okay. Here we go. What about this one? Good, that was a good job. That was really good, Butters.
What is that? X approaches what?
A.
A. If limit where L is a real number. So the limit as h approaches A is L. When L is a real number, which of the following must be true? A doesn't have to be true.
Why not?
Because it could be an open circle, like a point on like a hole in the graph, you know?
A hole in the graph?
Yeah.
Okay.
B, f of x is continuous at x. It doesn't have to be. It can still be a hole in the graph.
Okay.
Defined at, no, it's not defined. F of A doesn't have to be L. It could be some other point up somewhere. So it's none of these. It's E.
Yeah, because the graph, limit as x approaches A.
Yeah, it can look like that. It could have a dot somewhere else.
This knocks everything out.
Yeah.
Right?
Yes.
I mean, this knocks all 4 of them out.
Yes.
Okay.
So it's none of the above.
Okay, let's try this one.
What is your birthday?
When's my birthday? Why?
I don't know. We just want to know.
It's a week from Monday.
A week from Monday?
Yeah.
Nice. How old are you going to be?
I'm going to be 40.
Oh, my God.
Okay. How do you do that? But get Dennis back on the line.
Dennis, come on.
Is it just e to the square root of x?
Close. But why?
Plus c.
Why? Oh no, that's why. How can we prove that this?
Oh yeah, we need a.
How can we prove, Dennis, that is?
We need a 1/2 because you can separate it into 1 over square root of x and e to the square root of x.
So you want? What do you think the answer is?
With a half, 1/2.
Okay. How can we prove that this is incorrect? Which it is. It's not correct. It's close. How can you prove it?
Wait, no. Oh, I'm sorry.
Butters, no negative, Butters.
You flip the half. It's 1/2 as an exponent, so you're multiplying. You're dividing by a half, so you're multiplying by 2.
So it'd be 2e to the square root of x, right?
Yeah.
How can we prove that this is right?
Take a derivative.
Take the derivative, right? And you get it. Okay, Dennis, what about this one?
Oh, secant squared. 1 over cos squared is secant squared. And that's the derivative of tan.
So what's the answer?
Just e to the tan x plus c.
That's pretty good. That's pretty impressive, Dennis. You get a bell for that one. Hold on. hey, Dennis.
Mm-hmm.
Yeah, because you take the derivative of this is just e to the tan x times secant squared x, which is 1 over cosine squared x. Okay. Let's try this one here. I'm gonna have to think of a harder problem for you. What is that? Okay, what about that one?
U substitution.
Well, which one? Well, what's the how do you
1
do it?
plus ln x is u. So du.
Are you doing these yourself?
Yes.
Hey,
I know it. 1 over x.
Dennis, this is too easy for you. So u is 1 plus natural log of x.
Mm-hmm.
This is awesome, Dennis. You are the man.
I know.
You are the integrating man.
1 over x dx.
So what do we got there?
So you have 1 over u du.
1 over u du, which is what?
ln u. So ln of 1 plus ln x.
So it's natural log plus 1 plus natural log. Okay, you ready for here's going to be a harder one, okay? A little bit harder.
Can you move it down a little bit?
Yeah.
Okay. Thank you.
Well, it'd be harder if you can't see it. That's my goal here, that you can't see it. Okay. How about e to the natural log of x times arc sine of 2x times x squared all over cosine of 3x times x cubed plus 1. Okay, do that. Just kidding! Little joke. A little joke.
Calculus humor.
That's right. That's right. It was very funny, wasn't it? What is the I'm sorry. What's the integral of 1 over e to the x? How would we do that?
Rewrite it as e to the negative x.
Okay. All right. And what do we?
We need a negative out front.
So what's the final answer?
Negative e to the negative x plus
Negative
c.
e to the negative x plus c. Okay. What about this one? What about the integral of?
The joke you gave up on it?
What's that? What? I didn't hear that. What was that?
Oh, he thought it was real.
What was
The
that?
first one.
Oh, but what about what's the integral of cosine squared x plus sine squared x?
What is this x integral of this one?
What's that?
Good. That equals 1, so it's just x
X plus c.
plus c.
Yeah, but it's not 1, right?
What's the integral?
Well, cosine squared plus sine squared is 1.
But you know,
So it's 1 dx.
the answer's going to be 1.
Yeah.
It's 1. But you got to do it to x.
Who's talking back there?
They're conversing.
Okay, what is e to 2x over 1 plus e to 2x?
I'm going to put u again, u substitution.
What's the final answer?
It would be on the bottom and it's on the top.
Dennis?
1 half ln of 1 plus e to the 2x plus c.
You got the quicker.
Dennis?
Yeah.
Dennis, you're in good shape. Hey, great job, y'all. Have a great weekend. We'll see you next Thursday. Bye.